example that was
Yeah, you had the example.
Yeah.
You just followed along.
Okay. All right, guys, let's quiet down, please. We only got like 10 minutes left. So,
Right, let's go. Speed around. Speed around.
so why did the dart go farther when the blowgun had the longest length? Hopefully was our right. When it was longer, it went farther. Was that held true?
Yeah.
Why?
And more time to accelerate to a higher speed.
All right, so force times time is equal to the change in momentum. So if we increased, so the force stayed the same. Hopefully you tried blowing the same throughout the experiment. So the force stayed the same. So if you increase the amount of time, increase the distance of the blowgun, that should have increased the momentum. Right? That's your answer, number one. Okay. Let's see. Number two said, what was different about the shorter blowgun that did not allow for the blow dart to go as far? Well, the shorter blowgun just had less time, right? So this was a long blowgun. So the shorter one just had less time. Not too bad. Yeah.
Oh no, I'm trying to figure out the riddle of that.
Oh,
I think I have an answer though.
what's your answer?
You only get one.
Is it
No, you can get more than one.
dozens? Like as in like a baker's dozens?
It is dozens is the correct answer.
Oh!
You guys are the first class to get it.
Nice.
Undefeated.
So if you have dozens, you take one away. You take one of them, one of the letters away. I am 12.
Oh, that makes a lot of sense. That makes a lot of sense.
Dude, I took it so far. Talking to people face to face that aren't my family.
Oh, yeah.
All right.
I got thrown over quarantine. Quarantine is terrible.
That's what I'm talking
All
about.
right. Next one. Number 3. How does the lab explain force times time equals change in momentum? We got that. Number 4. What are 3 ways you could have made the dart travel a farther horizontal distance? What's one?
You can angle it up.
Angle. All right. Angle it up. What else? Yeah. Increase the length of the blow dart. Increase the length.
That's what I said.
Of the gun.
Yeah.
I tried to avoid. Yeah. We'll just put that.
I mean, it was all over our lab.
It's fine. It's fine.
It's the lab's name is Blow Gun. That's Blow Gun Lab. So
It's fine. It's fine. We're all good here. Any other ones? What? Yeah. Keegan?
Increase the height to like where it is above the ground.
Okay. I like that. Yeah. Increase the height.
You blow harder. More force.
Then when they did say.
Oh, I thought you said.
Increase the height at which you blew from. Exactly. Another one is.
Blow more force.
I like that wording. Blow more force. Okay.
Reduce.
There's 4. I have 1. Wow, you guys got all of mine except 1. Yeah.
Decrease the weight of the dart.
Decrease the
I
mass
wrote
of
that
the
down.
dart.
Okay. My third one was to make the inside of the gun more slippery.
You know, it's not a bad idea. That might actually work.
So- Increasing the lubricant,
Or like use a different material.
using a different material to decrease friction.
Yeah. Make it out of ice.
So, what if you use like a PVC pipe?
It'd probably be smoother.
Yeah.
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 There's another way. Make the pipe so it fits more, well, has less gap around the dart, but not tight enough that it compresses the dart.
So just find the perfect circumference.
Yes.
Yeah. Yeah. All right. All right. We nailed that one. Now, the last question. Pretty sure it's the last question.
Yeah.
All right, number 5 says, for the blowgun that was 35 centimeters long, what force did each person exert if the dart was in the barrel for 0.1 seconds when being shot out? Okay. So looking at this one, now no one had a blowgun that was 35 centimeters long, did they? So on this one, you have your time, you have the mass of the dart, what was the force? Man, so it's kind of hard to do this. So what you should have done is just use one of your force values or one of your velocity values. Okay, so I would do the farthest one. Okay, the farthest one was what, 18 centimeters? Was that the farthest one? 28 centimeters was the farthest, longest blowgun. All right. So what you guys could have done to solve that is force times time is equal to change in momentum. All right. So okay. So your time in this problem, it said your time was 0.1. Okay. The mass of the dart. Did you guys actually mass the dart? What did that end up?
Mass of the dart.
0.003.
1.22 grams.
Something like that.
That's what it was in the online.
All right. Now the initial velocity. What was the initial velocity?
So Brady used the online labs. That's not
That's fine. That's fine. What was your initial velocity? If you're 0. All right. Now, can somebody just share one of their longest? 15.5 was the highest velocity.
Sounds about right.
It's pretty good. All right. And that's how you would solve for force.
I was like, I got 2.
I know, I got 7.
All right.
I just did.
And is there any other questions on impulse, on the impulse lab? Not bad? All right. So, guys, we only have 6 minutes left. All right. So tomorrow we're going to cover a little bit more impulse. Maybe look at it. You know what? We got 6 minutes left. I got a problem for you guys.
Let's go.
There's a man going to the radio station.
Any soccer players in here? Does anybody play soccer? Beautiful. All right. All right. So I'm going to draw Tommy here real quick.
Go break something.
Tommy's wearing a soccer sweatshirt. He is all in. You want us to put this in our notes?
You don't have to. And then, yeah, that kind of looks like Tommy.
Yeah.
All right, so Tommy plays soccer.
Does.
All right. And so the goalie kicks it, kicks it really far. I'm not a big soccer person. I like to use my hands. I'm not coordinated with my feet. So like, it's a really talented sport to play. So the goalie kicks the ball, soccer ball. It's in the air, and then when it comes down, you try to jump and hit it with your head, right?
Yeah, I know a person who got a concussion from that.
Kind of ish, or hit your body or whatever. So the ball's coming, hits Tommy's head,
Oh, yeah, Tommy.
right? And when you're facing the ball and it's the goalie's that way, you kind of want to hit the ball backwards, right? You want to.
You gotta throw your head.
I don't know. I honestly don't know what I'm talking about, but it just goes with the
I don't
story.
know either. How to play soccer.
And it projectile that way.
That would be like if it hit straight in the middle and something like.
Tommy's just a guy.
Okay, okay.
He's just really good.
Tommy knows his geometry, okay?
All right. So going, actually, let me change colors. Going down. Negative 1.3. 4.7 meters per second. Okay.
So.
How is it faster?
Yeah, how's it faster?
He said concussion.
Oh, yeah, vector.
All right.
I love that.
If we know this, we know the soccer ball weighs 0.82 kilograms.
All right.
82 kilograms. So that's the soccer ball. And the only other thing we know is the time it took. All right. So Tommy's quick, right? 0.0067 seconds.
Oh, yo, that's a heck of a play.
0.0067 seconds.
That's a long with these guys.
What is the resultant vector? What's the resultant impulse? That's my question. What is the resultant impulse?
Okay. So we would find the hypotenuse of the left one.
Would you have to?
For the original velocity, right?
You want?
Oh wait, oh, I did the dumb stuff. Are you serious? I should have done
True.
That's unfortunately.
Soccer ball. It's a red soccer ball.
Wait, no, you don't even know
Force, or like if the time is that quick, the force would have to be so great, like that would have to get the concussion, like or maybe that quick.
Are you laughing at Tommy shattering the skull?
Yeah, there we go. Yeah, it would have to be like super hard. Like,
okay. I got it.
So if you ever see a problem like this, what'd you get?
I got about 3. I got 2.97.
I got 4.9.
Dang.
So you're pretty close. So if you ever see a problem like this, you would want to start by finding the impulse in the x direction. Okay, and then finding the impulse in the y. So if we're looking at the impulse in the x, all right, you're going to have mass times your velocity. All right. Actually, I'm going to leave that up. Well, I'll go over this tomorrow. All right. Guys, have a fantastic day.
First day back.
First day back.
It was
Feels
pretty
good.
boring without Brittle every day. Like I did it, but then some days I just did not.
Then I did it though, and you guys got it.
I know.
That
I
was
got
actually-
it. I've never done anything, so I'm so proud of it.
I'm proud.
I'm proud of you.